rings has the ring for polonium 218, 214 and 210, so we call that a polonium 218 halo. Now, why do we give it those names? Well, think about it. Why did we call the 8-ring one a uranium radiohalo? Because it was parented by uranium in the zircon in the centre. And the uranium gave rise to all 8 steps. So, if there was only one ring produced and it was a polonium 210 ring, what must have been in the centre? Only polonium 210. If we have 2 rings and it produced the 214 and the 218 rings, because you go down the decay chain, okay, it means that you only had originally polonium 214 in the centre. Why? Well, if you had polonium 214 in the centre, it would decay to 210 and produce the 214 ring, and then the 210 would decay and produce the 210 ring. I see a few heads nodding, so that means at least a few of you are following what I'm saying. And if you've got 3 rings, the 218 would have to have been in the centre to decay to 214 to decay to 218 to produce the other 2 rings, to get all 3 rings. So you follow what I'm saying? These radiohalos are easily identified as produced by the alpha particles from the last 3 decay steps, parented by those 3 isotopes of the rare element called polonium. By the way, it was discovered by Marie Curie, who named it after her native home of Poland. So that's the derivation of that name, polonium. Now, so far so good. That's easy to understand. What's the big deal? These polonium radiohalos are found with uranium radiohalos in many granites around the world. This is what I did in my research, looking at these biotite flakes, say in the Ruin granite of Arizona, or this granite in South Australia, the Shap granite in England, the granite east of San Diego. All of these granites had both uranium and polonium radiohalos in them. Big deal. Well, these polonium radiohalos, however, were described in a very famous US court case as a very tiny mystery. Why are they a very tiny mystery? By the way, the gentleman who made that comment at the time was the Deputy Director of the US Geological Survey, and arguably at the time the world's leading expert in potassium argon dating. He now works at the University of California, Berkeley radioactive dating laboratory. Why did he call these a very tiny mystery? Well, the answer is simple. These 3 isotopes of polonium are very unstable, and they only have fleeting existences. They have very fast decay rates. What are those decay rates? Polonium 210 only lasts on average for 138 days. Polonium 218 only lasts for 3.1 minutes. If you think that's fast, polonium 214 exists for 164 microseconds. You blink and it's gone. That's how fast it decays. In other words, if you started with 1 pound of polonium 214, in less than a second there'd be none left. That's how quickly it decays. So you can understand why these halos are a tiny mystery, because remember, the polonium 210 had to be in the centre of that polonium radiohalo, independent of uranium. If there was any uranium in there, you'd get the other rings. How could the polonium get to be in the centre of that radiohalo if the polonium only had a fleeting existence, measured in fractions of a second? Well, it means on the first thing is the polonium radiohalos had to form very rapidly. Okay? If it decayed so quickly, the alpha particles were produced so quickly, therefore the damage was occurred quickly, therefore the halos formed quickly. Now, Robert Gentry, who was the pioneer in this research, claimed that these polonium radiohalos were thus created and must be the fingerprints of creation. Why did he say that? Well, he claimed that there was no natural process capable of forming these polonium radiohalos because you need a concentration of at least 50% polonium in the radio centre, he said, all at once. In other words, you had to have, remember, you've got to produce between 500 million and 1 billion decays to make a visible halo. So you had to have between 500 million and 1 billion polonium atoms in the centre to produce that decay. And so he argued if it was there all at once, how would you get it all there at once if it only survived for a fraction of a second? He said, aha, God must have created it there in the rock. And he therefore said, okay, if the halos form rapidly, the polonium must have formed rapidly, and God must have created the polonium in place. Now, since this was in a granite, he claimed that these granites were also therefore created. Okay? However, why did God create the polonium radiohalos and then allow the uranium radiohalos alongside of the biotite flakes to then form over millions of years in the same biotite flakes? It doesn't seem to make sense. Furthermore, the biotite flakes containing these coexistent polonium and uranium radiohalos are often found in granites that can be shown to have formed during Noah's flood, for example. At a paper I presented at the 2003 conference in Pittsburgh, International Conference on Creationism, I looked at the Stone Mountain granite, the granite east of San Diego, and one of the granites in Australia, where there is evidence that those granites have intruded into and cooled and altered rocks that contain fossils that would have formed during Noah's flood, implying that the granites were intruded into those rocks during Noah's flood.